The next experiment we're going to do is we're going to start with a single bulb, and as you know, that single bulb will be very bright. And then we're going to compare that to two bulbs in series. So here's the single bulb. You'd say that's bright. And I represent the brightness by very dark yellow rays coming out from that bulb. Now if I replace that with two bulbs in series, they're dim, and they're equally dim. They're the same dimness. And I represent that with a yellow that's not so dark. Now, if we believe more flow, more glow, we would say there's lots of flow there in that bright bulb, and there's less flow in these bulbs that are dimmer. Now, in this circuit here, we've learned what goes around comes around. And so that means that the current that's flowing through the battery is the same as the current flowing through this bulb. If I call that 5, you want to say amps, I want to say quarts of blueberry juice per second. Either way, 5, that's got to be 5. Now, the $64,000 question is this. What's the current through this battery? Is it going to be that, or is it going to be that plus that? Talk to your neighbor. Which is it going to be? Is it going to be that through the battery, or that plus that? Talk to your neighbor.
That was a big budget. What was the question?
I saw your friend just walk in. That the girl who
Yeah,
usually
she's sitting.
Okay, by show of hands, how many think that this is the current through the battery? How many think it's this plus this? Okay. Now, we didn't agree. But I bet we'll all agree that those two bulbs are sharing the current through the battery. Do we agree on that? Everyone nod your head. Yes. Unfortunately, that word share has two meanings. I can share something like I share a book. I read the book, then I give it to you, you read the book, you take it back to the library. I can also share like I share a pie. I take half the pie, you take half the pie. Which way are these two bulbs sharing the current through the battery? Like a book or like a pie? Shout it out.
Book.
Pie. Folks, we still have that principle that you learned with the nichrome wire in tutorial. And that is what goes around comes around. If I put an ammeter here, here, and here, all three of those ammeters have exactly the same reading, and that reading would be just the current through that bulb there. Now, folks, these don't just have the same size current, it's the same current. If you take that electron, paint him green, and call him Fred, he's got to go through this bulb, and then he's got to go through that bulb to get back to the battery. When you take Fred and all of his friends, they go through this, then they go through that. It's not just the same size current, it's the same guys. It's the same flow. And it's smaller because the resistance in that circuit is larger. You remember when we took the two straws and put them end to end, it was harder to blow air through? When we add resistors in series, we increase the resistance. That's what's happening here. And if we use V equals R, the battery voltage stays the same. As the resistance gets bigger through the circuit, the current gets smaller through the battery.